Hi there. Today we're going to be talking about roots. And no, these are not the roots that you see at the bottom of trees and plants and stuff like that. These are math types of roots. So we're going to start talking about roots by talking about my back patio first. All right, so if the area of my back patio is 36 square feet, what are the dimensions of my patio? So should have mentioned that my patio is a rectangle, but I'll mention it now. So if I have a rectangular back patio and the area is 36, how do you find the area of a rectangle? You multiply length times width, or base times height, right? Length times width, length times width. All right, so what are two numbers that I could multiply together to get 36? All right, well, two easy numbers, 1 and 36. All right, work, but does that make sense for a patio, 1 foot by 36 foot? That's not a very wide patio. So that is not the dimensions. Those are not the dimensions of my patio, but they're possible, so we're going to write them down. All right, what else could be a possibility? I could have 2 feet by, what, 18? 2 times 18? Yep. Could be 3 times what? 12? 3 times 12? Could be 3 times 12, yep. All right, that's 36. About 4. 4 times 9, yep. 4 times 9 would work. 4 feet by 9 feet would give me 36 square feet. Okay, and what about 5? Nope, 5 doesn't work. What about 6? Yep, 6 times 6. All right, so I have lots of possibilities for the dimension of my patio, but based on what I've told you, you would know for sure which one it would be. Sorry, my dog. Somebody just got home, so they don't know I'm recording. Hopefully they'll be quiet for us. All right, so if my back patio is a square, though, if I tell you that, then the dimensions of my patio would be what? Could you narrow it down? Well, a square, right, has to be the same size. So the only two numbers that would give me the same side, length and width, would be 6 and 6. So the dimensions of my patio are 6 by 6. All right. When you have a number, okay, like this, 6 times 6, what's a way to write that, right? When it repeats like that, you can say this is 6 squared, right? All of these numbers here, 1, 4, 9, 16, and 25, are called perfect squares. Okay, why are they called perfect squares? Because 1 is the same thing as 1 squared. 4 is the same thing as 2 squared. 9 is 3 squared. 16, 4 squared. 25 is 5 squared, okay? They're all found by squaring an integer, all right? So those are squares, but today we're looking at roots. So one type of root we're going to be looking at is a square root. The two are related, okay? Squares and square roots. A square root is kind of like going the opposite of squaring something. So a square root is what you got before you squared it, right? The square root, there's a symbol for square root, and it's called a radical sign. It looks like this. It kind of looks like checkbox. Some people think it looks like division with that little check there. This indicates that you're taking the square root, the positive square root of something. So when you see it in front of a number, it's saying the square root of 25. All right, so these two are related. They're kind of opposite operations. If you square 5, you get 25. If you take the square root of 25, it's asking you, all right, what number did you square to make 25? Just the 5. Okay, it's just one of those, right? One of the two equal factors. All right, so here's how it works. This is the square root of 36. So what you're asking is what number squared gives you 36? What did we just say? 6 times 6 gives you 36. So one of those, just the 6, is the square root of 36. All right, and if it's positive, it's positive. All right, look at this one. What number squared is 144? So 12 times 12, all right? 12 squared is 144. So just one of those is the square root. Okay, this time, okay, the number outside is going to be, this is a plus and a minus. It means it could be positive or it could be negative. And it's just a short way to write that. You could write 12 or negative 12, all right? This plus or minus is kind of a short way to write that. All right, look at 3. This is 144. This is 1.44. All right, so those are similar, not the same. Okay, if I know that 12 times 12 is 144, Okay, how could I change these numbers so that it's 1.44 now? All right, well, if I put a decimal here in front of the point, or in front of the 1, then I would have 0.12, and I would have to move it 2 places, but these would not be the same anymore. If I put the decimal here, all right, I still get 144. This part doesn't change. But the decimal would go where? Right here. Are these numbers the same? Yes. All right, so what I've said is 1.2 times 1.2 is 1.44. Okay, but a square root just asking for what that is. One of those is 1.2. All right, here I'm doing the square root of 9 over 64. So when you're doing fractions, you can kind of take the square root of the top and the bottom, sort of divide those up. So what number times itself is 9? 3 times 3, right? What number times itself is 64? 8 times 8, right? So that's the same thing as 3 eighths times 3 eighths. And because this negative's out front, it just means that that's going to change my number to a negative 3 eighths. All right, this part, right, is just 3 eighths, but this makes it negative. All right, and then this number 5, it says the square root of negative 16. So I'm trying to decide, is there a number that gives me a negative 16? All right, well, I know that 4 times 4 is a positive 16. So what gives me a negative 16? What's negative 4 times negative 4? Okay, that's also, right, if I use sleeping man, negative times a negative is still positive. The only way to get a negative 16 is to do 4 times negative 4. That is negative 16. Okay, that's negative. Okay, but are these the same? No. Okay, if you can't find two numbers that are equal, that give you this number inside, all right, then it's either not a perfect square, okay, or it's not possible, all right? So I know that 4 times 4 gives me 16, but not negative 16. There's no number I could multiply times itself and get a negative. So this one's not possible. Okay, I can't multiply two numbers and get a negative. This one, why is this one okay? Because the negative's outside. So this part I could do, and then the negative outside made it negative. All right, so you're going to see that we use square roots sometimes to solve equations, right? If I'm trying to solve 100 equals a squared, I'm trying to figure out what a is. Well, a squared just means 2a's. So what number times itself is equal to 100? Well, really, all you're doing is finding the square root. What number times itself? That's what we were doing up here, right? You can write it like this. What's the square root of this? So that what number times itself is equal to a squared? Just a. What number times itself is equal to 100? 10, right? 10 times 10. Is that the only number times itself, though? Okay, so when you're solving equations, because we're deciding to do the square root and it's not somebody asking us for the square root, we also have to think about, is there anything else I can multiply times itself that gives me a positive 100? Well, what about negative 10? Is negative 10 times negative 10 also 100? Yes. So a could be 10, but it could also be negative 10. Is there a shorter way to write that? Yeah, you saw it earlier. A could be written as plus or minus 10. It could be positive 10 or it could be negative 10. All right, look at this one. X squared means x times x. You just want to know what 1x is. That's how you solve an equation. You just solve for one of the variables. All right, so basically you're taking the square root. All right, so this would just be x. Okay, what factor times itself is x squared? X. Okay, what number times itself is 0.04? Well, I know that 2 times 2 is 4, but how do I make it a decimal? If I put the decimal in front of the 2, then I have to move the decimal 2 places. So this becomes 0.04, so that works. So I know that 0.2 times 0.2 is equal to 0.04, but is that the only way to get it? Okay, remember with equations, I have to think about negatives. Is negative times a negative, all right, also going to be positive? Yeah. So this could be a plus or minus 0.2, or you can write that with a 0 if you like that better. Plus or minus 0.2. And then this last one, y squared times y squared. All right, if I take the square root, okay, if I ask myself what times itself is equal to y squared, it would just be y, right? Here, what times itself is 9? Well, 3 times 3, right? What times itself is 49? 7 times 7. So 3/7 times 3/7 works. Okay, so this is going to be 3 over 7, right? Positive times a positive gives me a positive 9 4/9, but so would a negative. A negative times a negative would give me a positive 9 49. So when it's an equation, I have to show that. It could be either one, plus or minus 3/7. All right? And roots, though, square roots are not the only kind of roots, and perfect squares are not the only kind of perfect squares. Okay, so there are perfect squares, right, but there are also perfect cubes. So that's when you have something like this, 2 to the 3rd power. We know it's 2 times 2 times 2, so 8 is a perfect cube because it can be written like this, 2 to the 3rd power. 27 is a perfect cube because 3 to the 3rd is equal to 27. Okay, and there are others, but these are just 2 examples. So just like there are perfect cubes, there are cube roots. We have square roots and perfect squares. We have cube roots and perfect cubes. Cube root is one of 3 equal factors. All right, so now you're trying to figure out what did they cube in order to get the answer. So cube roots are also going to use the radical sign, but the index, you're going to see the index is this little tiny number in front of the radical sign. Okay, that's going to be a 3 instead. So the 3 tells you it's a cube root. When it's a square root, there's no number there. Now they could put a 2 there if they wanted to, but they don't have to. Square root's the most common root that you're going to work with. All right, so cube root of 125. So I'm asking myself, what number do I multiply 3 times in order to get 125? Now, there are some that are very common, and so you'll start to recognize them. 5 times 5 is 25. 25 times 5 is 125. So the cube root of 125 is 5. All right, cube root of negative 27. Okay, well, let's not worry about the negative yet. Let's just talk about the 27. So I have 3 times 3 times 3, because, right, this is 27 up here. 3 times 3 is 9. 9 times 3 is 27. All right, but I want it to be a negative 27. Now up here, I couldn't do negative 16. But that's when I was squaring something. So are cubes any different? Well, let's try negative. Okay, now remember they have to all be, they have to be positive, they all have to be negative. So let's try it if they're all negative. A negative 3 times a negative 3 is a positive 9, right? But what's a 9, a positive 9 times a negative 3? Positive or negative? A negative times a positive is negative, so negative 27. So if you take, can you take the cube root of negative 27? The answer is yes. It would be negative 3, right? Because you can do that with cube roots, right? It can you use to solve equations. Here, y to the 3rd power means 3y's, right? So if I do the cube root, then I can figure out what y is. If I do the cube root of this, I'm asking myself what number 3 times is y cubed? Well, y. So what number 3 times is 1,000? Okay, well, hopefully this is one you know too. It's 10 times 10 times 10. So just one of them, right, is y. Y equals 10. All right, and really cube roots and perfect squares or square roots are not the only types of roots. You can have any kind of root. You just need to pay attention to the number in front of the radical sign. So, so I'm asking, can you solve this one? This is a 4th root, okay? So just like you have squared and cubed, and then after that you have something to the 4th power. Once you get to the 4, it's just the 4th root or the 5th root or the 6th root. What do you think that means? It means what number do you multiply 4 times in order to get 16? Okay, does 4 times 4 times 4 times 4 work? No, the first 2 4 give us 16, so it can't be that. So what's another number you could try? How about 2? What's 2 times 2? 4. What's 2 times 2? 4. Is 4 times 4 16? Yes. So, can I find the 4th root of 16? Yes. 2 times 2 times 2 times 2. So how many of these are the 4th root? Just 1. 2. All right. Notice on your notes you were given, and behind this page you should have a page that looks like this. Okay, so this is a good little cheat sheet because there's a list of perfect squares and perfect cubes. Now these are not all because you could keep going. Okay, but these are some of the most common ones. In fact, anything 1 through 10 or even 1 through 12 you might want to just start memorizing because you're going to use them so often. But definitely keep this handy when you're doing your homework. We're talking about it in class, and it'll help you figure some of these cube roots and square roots out a little easier. All right, see you soon.